Okay, so almost everybody is saying that pattern 3 is the best fit because all those electric field vectors, how do they compare? Same magnitudes. Okay, they're the same magnitudes. We would expect that because in the steady state, the current should be the same everywhere in that wire, right? And if everything else is the same, N is the same, A is the same, that means V should be the same everywhere in that wire. And then from V equals UE, the electric field should be the same everywhere in that wire. And the electric field's got to point along the direction of the wire to drive the current in that direction, okay, or namely drive the electrons in the opposite direction, okay. But there's something weird here. If I were to draw a battery, I'll assert to you that one way we can think about a battery, and it's not exactly a precise picture, but it's a simple enough model to get us through the day, is that we can think of a battery kind of like two ends of a capacitor. Okay, so the positive end has some positive charge on it, and the negative end has some negative charge on it. And then we can think of it as having some means of driving charge from one plate to the other. And in a sort of a mechanical model, you can imagine turning a crank on a conveyor belt that just brushes up against one plate, drives charge onto the other plate, and maintains that charge separation. Okay, so a battery maintains a charge separation. Of course, in a chemical battery, it's not a conveyor belt, right? But it's some chemical reaction that maintains that charge separation. Well, if that is the case with the battery, what would we expect the electric field of the battery to look like if we have a positive charge on that end, negative charge on the other end? So, for example, the electric field of the battery here would be in what direction? That way, okay. And the electric field of the battery at this point would be that, which way? Same direction, right? Same direction. The electric field of the battery would be what at this location? Opposite direction. What would be the magnitude of the electric field due to the battery be? Compared to those two, those locations which are close to the terminals, we would expect it to be what? We would expect it to be smaller, right? But then we've got a problem, because if the electric field of the battery is smaller here, then the drift speed would be smaller and we wouldn't have a steady state, right? I mean, it's got to be the case that 3 is the correct answer in order to have a steady state. But if we think that the electric field is only due to the battery, we've got a problem. So what we're going to talk about next time is we'll see that the electric field, the net electric field that's driving the current inside those wires, is not just due to the battery. It's not just due to the battery, and we'll talk about that next time.